Activation energy. A chemical reaction is a process involving the breaking of bonds and the formation of new bonds. The reacting molecules should collide to undergo reaction. However, all collisions of molecules cannot result in a chemical change. A simple analogy explains this point. Imagine, two cars are running on a narrow road toward each other. As they approach each other, the drivers apply brakes to slow down the speed, but they fail to avoid the accident. Thus, cars collide, but due to very slow speed, their engines are not damaged. Damage to the engine is equivalent to a chemical reaction. Similarly, in a gas phase reaction, when two molecules approach each other, their speed decreases due to the increasing repulsive force between them. Their kinetic energy goes on decreasing, and the potential energy goes on increasing with the decrease in the distance between them. If the molecules do not have sufficient kinetic energy, the increasing repulsive force will push them back. A collision of this kind does not result into a chemical reaction. For a fruitful collision, molecules should collide with a certain minimum amount of energy. The minimum amount of kinetic energy required for a molecule to react is known as the activation energy, EA. Speed of all molecules is not equal. The average speed of molecules in a gas phase is constant at a constant temperature. Therefore, those molecules which do not have sufficient kinetic energy cannot react in spite of undergoing collisions. Molecules which have energy EA or more are capable of undergoing a reaction on collision. However, all collisions between energetic molecules may not result into a chemical reaction. In addition to the energy requirement, it is also essential that the colliding molecules should collide at a proper angle. Remember that if two speeding cars have an accident from improper directions, their engines will not be damaged. Instead, the body plate may just get pressed. Let us consider the collision between HI molecules. If these molecules collide with sufficient energy at a proper angle, they will produce H2 and I2. If they collide at an improper angle, the reaction would not occur. The following conclusion can be drawn from the above discussion. For a reaction to occur between molecules, 1. Collision must occur between the molecules. 2. The colliding molecules must have a certain minimum amount of activation energy EA. And 3. The molecules must collide in a proper direction. Each of these conditions have been necessary. Carbon will not burn in air due to the collision between the oxygen molecules of air and carbon particles. In other words, chemical reactions would not occur at a fast rate at room temperature. As the distance between the molecules colliding fruitfully decreases, the potential energy of the molecules increases. When these molecules collide, first they combine and produce a molecule having a very short life and the maximum potential energy. This molecule is known as an activated complex. The bonds in activated complex molecules are very weak, and they readily break due to the vibrational motion of the molecule giving the product. As molecules are formed as a result of breaking, the activated complex goes apart. Their potential energy goes on decreasing. If the minimum potential energy of products is greater than the potential energy of reactants, the reaction would be endothermic. If the minimum potential energy of a product is less than the potential energy of reactants, the reaction would be exothermic. The difference between the potential energy of activated complex and the potential energy of the reactants is the energy of activation of the reaction. The activation energy for a reverse process of a reversible reaction is ERA. Thus, the enthalpy change in a forward reaction is equal to the difference between the activation energy EA of a forward reaction and the activation energy ERA of a reverse reaction. Delta H is equal to EA minus ERA. If EA is less than ERA, then delta H is negative. This is an exothermic reaction. If EA is greater than ERA, then delta H is positive. This is an endothermic reaction.